In this video, we'll be talking about the integral regarding secant and cosecant. So, let us start first with regarding having an even exponent. So, let us start off with the integral of sec²x. The integral of sec²x, dx would be equal to tangent of x. And don't forget to add plus c. This is because of the reason that the derivative of tangent of x is equal to secant squared of x. And so, by reverse, by taking the integration of sec²x, it would be equal to tangent of x. Let us move on to the integral of secant to the power 4 of x. So, the first thing you're going to do here first is to factor out 1 secant squared. So, this would be secant squared of x and secant squared of x dx. Now, the reason that we will factor out secant squared x, this would be later be a part of du. But I will be explaining that later on. So, the next step, when you factor out secant squared of x, this is what's left. So, transform this into its trigonometric identity. Know that secant squared of x would be equal to tangent squared of x plus 1. So, the remaining term, transform this according to its identity. So, this would be the integral of tangent squared of x plus 1 multiplied by secant squared of x dx. And so, distribute secant squared x in this parenthesis. So, this would be the integral of tangent squared of x multiplied by secant squared of x plus secant squared x multiplied by 1 is simply secant squared of x, all multiplied by dx. And so the next step would be to split this integral into two parts. You can see here, this is one part and this is the other part, separated by an addition sign. So this would be the integral of tangent squared of x multiplied by secant squared of x. Don't forget to add dx. And since we are separated by an addition sign, this would be plus the integral of secant squared x dx. And so, let us use u substitution. Let u here be tangent of x. And so, the derivative of tangent of x is simply secant squared of x and multiply this by dx. Now, when you are confused on what term should you use u substitution, whether it is tangent of x or secant of x, just do trial and error. Example, if you use u substitution here, let's say it is secant of x, the derivative of secant of x would be equal to secant of x tangent of x and multiply this by dx. So, if example, you substitute it into this equation, so this would be the integral of tangent squared of x multiplied by secant x. Since what we use here is u equals secant of x, this would be u squared, and multiply this by value of dx. This is dx, so transpose secant x tan x to the other side. So dx right here would be equal to du over secant x tangent of x. So this would be equal to du over secant x tangent of x. And so this is now the part where you will see whether your u substitution is correct or not. So you can see here tangent of x would cancel. So you are left with tangent of x multiplied by u squared multiplied by du over secant of x. If the equation is not simplified, then what you substituted is wrong. Let me show you how, if it's the correct way. So we cannot use u equal secant of x here. And so instead we will use this one that I used earlier, which is u equals tangent of x. And so taking the value of dx transpose sec²x, so this would be dx would be equal to du over sec² of x. And so let us substitute it into this equation. So this would be the integral of tangent of x is u, but since this is squared, this is u squared. And now you can see here, that's why I called this du earlier. Du right here is equal to sec²x dx. So as you can see here, it is similar. So this would be multiplied by du plus the integral of sec²x dx. This is also equal to du. So I just realized this is not necessary because it was given right here now. So this is also equal to du. Now you can see here now the integral is simplified. There is no like complicated stuff like tangent or any trigonometric parts here. And so let us take the integral of this. U squared du, the integral of this would be equal to u to the power of 3 over 3 plus the integral of du is simply u. And don't forget to add plus c. And so the last step right here would be to substitute the variable back into its equation. Our variable here is u. And so u here is equal to tangent of x. So I'll just be putting u down. So this would be 1/3 u cube, or substitute u back into its original equation, which is tangent cube of x, since this is u to the power of 3, plus tangent of x plus c. Let us continue with the integral of secant to the power 6. So, as usual, factor out 1 secant squared and put it beside dx. So this would be secant to the power 4x and the factor out secant squared of x dx. And so, make sure to transform the rest. This is the thing that you should transform this. But since what we have here is secant to the power of 4, we need sec²x. And so, let us put it into the form of sec²x. So this would be the integral of secant² of x raised to the power of 2. This has the same value of secant to the power of 4. And so, let us transform secant²x into its identity. So this would be tangent squared x plus 1 raised to the power of 2 multiplied by secant squared of x dx. And so, the next step would be to use u substitution now for simplification. Let u here be tangent of x. And so the derivative of tangent of x is simply secant squared of x and multiply this by dx. And so by substituting it, you would have the integral of u squared plus 1 raised to the power of 2, and secant squared x dx is simply equal to du. Now our equation looks like much more neater. And so expand this next. So this would be u to the power of 4 plus 2u squared plus 1 raised to the power of 2 multiplied by du. And so, let us split this integral apart into 3 parts. First, second, third. So this would be the integral of u to the power of 4. Wait, this should not be squared. I am sorry for that mistake. Multiplied by du, because remember you have to distribute du amongst this first. Plus, since this is plus, the integral of we can put 2 outside the integral, so this would be u squared du plus the integral of 1 multiplied by du is simply du. And so let us take the integral of the first part. This would be u to the power of 5 over 5 plus, put 2 here, and take the integral of u squared, which is u to the power of 3 over 3. And the integral of du is simply u. And so, let u put back into its original form. So this would be 1/5 tangent to the power of 5x plus 2/3 tangent to the power of 3x plus tangent of x plus c. Now, let us move on with regarding to cosecant x, but still it's in the even exponent. So, the integral of cosecant squared of x is simply equal to negative cotangent of x plus c. The reason for this is because of the similar case earlier with secant. This is because the integral of cotangent of x would be equal to negative cosecant squared of x. And so by taking the integral of cosecant squared of x, we would have a value of cotangent x. And since what we have here is a positive cosecant squared of x, not negative like in here. And so the integral of positive cosecant x would be equal to negative cotangent of x. Let us move on. The integral of cosecant to the power 4 of x. So, with similar case with secant earlier, just factor out 1 cosecant squared x and put it amongst dx. So, this would be the integral of cosecant squared of x multiplied by cosecant squared x dx. Remember, this is once again part of du. And so, what we have here left, we will transform this according to its identity. Know that cosecant squared of x would be equal to cotangent squared of x plus 1. And so transform what we have left here into its identity. So this would be the integral of cotangent squared of x plus 1 multiplied by cosecant squared of x dx. Distribute cosecant squared of x in this parenthesis. And so, we can split this integral into 2 parts, separated by an addition sign. So, this would be cotangent squared of x multiplied by cosecant squared of x dx plus the integral of cosecant squared of x dx. And now, we can now substitute. Let u here in this case be cotangent of x. And so, the derivative of cotangent of x would be equal to negative cosecant squared of x multiplied by dx. As I said earlier, you can first substitute the cosecant squared of x. And if you see that it is not simplified, that means what you substituted is wrong. And so just move on. Basically, this is just like a trial and error, especially if you don't have any experience in integrating. But you will learn of it as time passes by. And so let us substitute this. So this would be the integral of cotangent of x is u. But since this is cotangent squared, this would be u squared multiplied by cosecant squared x dx. It is the same as du. But since this is negative, this would be equal to negative du plus the integral of cosecant squared x dx again is the same as du, but make this negative since what we have here is a negative cosecant squared x. And so simplify this. We can put the negative sign outside the integral. So this would be equal to negative the integral of u squared du minus the integral of du. So taking the integral of u squared, this would be u to the power of 3 over 3. And the integral of du is simply u plus c. Thus, the final answer for this would be equal to negative 1/3 cotangent cube of x minus cotangent of x plus c. Lastly, for the even exponent, this would be the integral of cosecant to the power 6x. So, once again, factor out 1 cosecant squared x and leave the rest to be transformed. Once again, this is part of du, and so the rest transform this. Note that cosecant to the power 4x is equal to cosecant squared of x, all raised to the power of 2. Just like what we did in the second earlier, so this is why it is raised to the power of 2. Because what we need here is a form of cosecant squared x. And so, in order to simplify this first, you can expand this first and multiply and distribute it. But what we are going to do here is to substitute it first in order to simplify. Let u here be cotangent of x once again. The derivative of cotangent of x is negative cosecant squared of x multiplied by dx. And so this would be the integral of u squared minus plus 1, all raised to the power of 2. Cosecant squared x dx is equal to du. But since what we have here is a negative cosecant squared x, this would be equal to negative du. And so simplify this first. Put the negative sign outside the integral. So what you have here left is the negative integral of u squared plus 1 raised to the power of 2 of du. And so, expand the expression first. So this should be u to the power of 4 plus 2u squared plus 1 of du. And so, if you want first, we can split the integral into 3 parts. So this should be negative and put a bracket now. In order to represent, this would be the integral of it. So this would be the integral of u to the power of 4 du plus 2 the integral of u squared du plus the integral of simply du. If you don't want to put a bracket on it, you can just distribute the negative sign, but I will not do that first. And so what we have here is to integrate this now one by one. So what we have here is integral of u4, which is u to the power of 5th over 5, plus integral of u squared is u to the power of 3 over 3, and the integral of du is simply u plus c. And so if you want, you can distribute the negative sign. So what we have here is negative u to the power of 5 over 5 minus 2/3 u to the power of 3 minus u plus c. And so our final answer right here would be equal to negative 1/5 cotangent to the power of 5th of x minus 2/3 cotangent to the power of 3x minus cotangent of x plus c. Let us now move on with the integral regarding odd exponent. So let us start with the integral of sec⁴x. So if you can see here, you really cannot do anything like substituting or something. So what we're going to do here is to make a trick or some sort. Just know that this is equal to the integral of sec⁷x multiplied by 1 dx. So what we're going to just do here is to make a value that is simply equal to 1. So this would be the integral of sec⁷x, and that value of 1 right here is equal to sec⁷x plus tangent of x over sec⁷x plus tangent of x. So if you divide this, you will have value of 1. So we did not like break the rules or something. And now multiply sec⁷x in the numerator, so you would have the integral of sec²x plus sec⁷x tangent of x over sec⁷x plus tangent of x. The reason you're doing this is because you need to have a u substitution, and so let u here be, substitute the most complicated part. In this case, it is the denominator here. Let u here be sec⁷x plus tangent of x. And so the derivative of this one, so take the derivative of sec⁷x first, which is equal to sec⁷x multiplied by tangent of x, and the derivative of tangent of x is sec⁷ squared of x, all multiplied by dx. And so if you transpose this to the other side in order to get the dx value, this would be du over sec⁴x tangent of x plus sec²x. And so let us substitute the value. This would be the integral of sec²x plus this value over u, because this is what we substituted it as, and multiply this by value of dx, which is du over sec⁴x tangent of x plus sec²x. And so you can see here now that we can simplify, because the sec⁴x tangent here would cancel and the sec²x would also cancel. So what you are left with here is equal to the integral of du over u. And so the integral of du over u, this is based on the logarithmic property. The integral of dx over x is equal to ln, the absolute value of x plus c. And so this should be equal to ln, absolute value of u plus c. And so our final answer for this one would be equal to natural log the absolute value of u, which is sec⁴x plus tangent of x plus c. So make sure to remember this answer regarding sec⁴x, because this will be used further on. Next up is the integral of sec³ of x. So first thing we're going to do here is to factor out sec²x and make this a part of dx also. So this would be the integral of sec⁴x multiplied by sec²x dx. As you can see here, unlike with the even exponent, there is no squared here, so we cannot use the property of sec²x would be equal to tangent of x plus 1. We cannot do that. So what we're going to do here is to integrate by parts. The formula for this would be equal to u multiplied by, is the integral of u multiplied by dv would be equal to u multiplied by v minus the integral of v multiplied by derivative or du. If that's too complicated, we can just use the di table method. And so what we want to take the derivative on here is sec⁴x. And our integration here is sec²x dx. And so the derivative of sec⁴x is sec⁴x tangent of x. And the integral of sec²x is simply tangent of x. So this would be plus and minus, and multiply this by the integral. And so what we have here is sec⁴x and multiply this by tangent of x. And what we have here is minus multiplied by integral of sec⁴x tangent of x. Technically, if you take the derivative of this, you would have a value of dx also. And multiply this by tangent of x. And now that we have our values here, let us simplify this first. Tangent of x will multiply with each other. So you have tangent squared of x multiplied by sec⁴x dx. Let me just clear some space here. Now, what we're going to do here, we can see here, tangent squared of x. So, wait. This should be tangent squared of x, I mean. And so, what we're going to do here, next regarding this integral, is to transform it, because we have a tangent squared x here. So, if you transpose one to the other side, what you have here is tangent squared of x would be equal to secant squared of x minus 1. Because we can't really do much anything with a secant x, so we must focus on tangent squared of x here. And so copy the first part first. And so transform tangent squared of x according to its identity, which would be secant squared x minus 1 multiplied by secant of x dx. And so distribute secant x into this parenthesis. So this would be secant to the power 3x minus secant x dx. The next step would be to split this integral into two parts, separated by a minus sign. So this would be secant cube x dx. And so what you have here is, since this is a negative and this is a negative, it would be multiplied. So this would be positive, the integral of secant x dx. And now, as you can see here, we have secant cube of x. But as you can also see, our problem here is equal to the integral of secant cube of x. So what we're going to do here is to equate it to each other. Note that this equation we are solving is equal to this problem. So we'll just rewrite this. So copy the first part. This would be the integral of secant cube x dx. This would be equal to this value right here. Let me just write this. Now that we have that, we can now subtract this and put it to the other side. So this would be, add. So add the integral of secant cube of x dx to both sides in order to get rid of this one. So what we have here left is the integral of secant cube of x dx is equal to secant x tangent of x plus the integral of secant x dx. Now that we have cleared this, in order to have the value of simply integral of secant cube of x, divide or multiply both sides by 1/2, or just divide both sides by 2, but I will just put 1/2, and so multiply this also by 1/2. Wait, let me just rewrite this. So this would be multiply this side by 1/2 and multiply this side also by 1/2 in order for the 2's to cancel here. So what you have left here is simply the integral of secant cube x dx. This would be equal to 1/2 multiplied by secant x tangent of x plus 1/2 the integral of secant x dx. And so, as you can see here, sec⁴x dx, as we had solved earlier, just copy this. Plus 1/2 multiplied by the integral of sec⁴x dx earlier. What you had solved there is natural log the absolute value of sec⁴x plus tangent of x plus c. And so our final answer here, I will just bring down this. So this would be the answer for the integral of sec⁵ of x dx would be equal to 1/2 sec⁴x tangent of x plus 1/2 the natural log the absolute value of sec⁴x plus tangent of x plus c. Next up is the integral of secant to the power 5x. So as usual, factor out 1 sec²x first. And so the next step would be to integrate all of this by parts. Let this be u and let this be dv according to the formula right here. The integral of u multiplied by dv is equal to u multiplied by v minus the integral of v multiplied by du. And so u right here is equal to sec⁵ of x. The derivative of sec⁵ of x, this is chain rule, so focus on the exponent first. Bring down the exponent and subtract this by 1. And next up is to multiply it by its inner portion, which is simply sec⁵x. The derivative of sec⁵x is simply sec⁵x tangent of x. So multiply sec⁵x together. So what you have here is 3 sec⁵x tangent of x. Next up is dv, which is sec²x dx. And now, this is reverse, so the integral of sec²x is equal to tangent of x. So substitute the parts that are given here. So u here is sec⁵ of x multiplied by value of v, which is tangent of x, minus the integral of v, which is tan x, and multiply this by du, which is this, which would be 3 sec⁵x tangent of x dx. So simplify this. Tangent and tangent would multiply, so you have tangent squared of x, and you can put 3 outside the integral. Wait. And copy the rest, which is sec⁵ of x dx. Now, next step would be to transform tangent squared x into its identity. So tangent squared x is secant squared x minus 1 multiplied by secant cube x dx. Distribute secant cube of x in the parentheses. So this would be secant to the power of 5, because 2 plus 3 is 5, minus sec³ of x dx. Split the integral into two parts. Minus 3 the integral of secant to the power 5x dx, and negative 3 multiplied by a negative would be equal to positive 3 integral of secant³ of x dx. Now this is the same similar situation as we did in the second cube earlier. Know that the integral of sec⁵x dx is equal to this equation. So let us equate it to each other. Would be equal to this value. The sign that you will do this equation is that if you see a similar problem, such as integral of secant⁵x as the initial problem, so just equate it to each other in order to eliminate it. Because if you don't, you will just go into a loop or just around in circles. And so, add 3 integral of secant⁵x dx to both sides. So what we have left here is 1 plus 3 would be equal to 4. The integral of secant to the power 5x dx. This is equal to, this will cancel out, secant³ of x tangent of x plus plus 3 the integral of secant³x dx. And so the next step would be to revert it into its original form, which is integral of secant to the power 5 of x. And so multiply both sides by 1/4 in order to get rid of the 4 here. And so our initial value right here now would be equal to the integral of secant to the power 5x dx would be equal to 1/4 secant³ x multiplied by tangent of x plus 3 multiplied by 1/4 would be equal to 3/4 the integral of secant³ of x dx. Now this is what I told you earlier, to take note of the answer in our previous problem because they are all related. Plus 3/4. And so the integral of secant³x dx, we solved that earlier, and the answer for that is equal to 1/2 secant⁵x tangent of x plus 1/2 the natural log absolute value of secant⁵x plus tangent of x plus c. And so our final answer right here would be equal to 1/4 secant³ of x tangent of x plus 3/4 multiplied by 1/2 is equal to 3/8. Sec⁷x tangent of x. 1/2 multiplied by 3/4 is also 3/8. The natural log of the absolute value of sec⁷x plus tangent of x plus the constant of integration. Let us move on with the integral of cosec⁷x. So just like with the second, multiply it by a value of 1. And so that value of 1 would be equal to cosec⁷x minus cotangent of x over itself. And so multiply it. And so let u here be this value right here, which would be cosec⁷x minus cotangent of x. The derivative of cosec⁷x is equal to negative cosec⁷x cotangent of x. And the derivative of cotangent of x would be equal to negative, so this would be positive now, cosecant squared of x. And multiply this value by dx. And so dx right here now would be equal to du over negative cosecant x cotangent of x plus cosecant squared of x. The next step would be to substitute these values. So you would have the integral of this over u and multiply this by the value of dx, which would be du over negative cosecant x cotangent x plus cosecant squared of x. So cosecant x cotangent of x would cancel, negative I mean, and cosecant squared x would also cancel. So you are left with the integral of du over u. So the answer, the integral of du over u is simply the natural log of the absolute value of u plus c. And so substitute u back into its original form. This would be the natural log of the absolute value of cosecant x minus cotangent of x plus c. The integral of cosecant to the power of 3. So once again, factor out 1 cosecant squared here. Keep in mind that the rules regarding secant and cosecant are the same. So this is also part of du. And so the next step here is to integrate this by parts. Let this be u and let this be dv according to this formula, which is u, the integral of u dv would be equal to vu, would be equal to u multiplied by v minus the integral of v multiplied by the derivative of u or du. And so let us take the value here. U here is equal to cosecant of x the derivative of cosecant of x would be equal to negative cosecant x cotangent of x dx. And dv right here would be equal to cosecant squared of x dx. And so, taking the integral of cosecant squared of x, it is equal to negative cotangent of x. And so, substitute all of these values. U here is cosecant of x, and v here, wait, I made a mistake here. This should be v and not u. So this should be multiplied by negative cotangent of x. So we can just put the negative on this side. So this would be negative cosecant x multiplied by cotangent of x minus the integral of v, which is negative cotangent of x, and multiply this by du, which is negative cosecant x cotangent of x dx. The negative here would cancel, so this would become positive. So let me just simplify this. The negatives here would cancel each other out. And the cotangent here would be multiplied to each other. So you have a cotangent squared x multiplied by cosecant x dx. And so you can see here again, we have a cotangent squared of x. Note that the property of cosecant squared of x, this would be equal to cotangent squared of x plus 1. And so, if you transpose this, cotangent squared of x right here would be equal to cosecant squared of x minus 1. So, we can substitute cotangent squared of x in this case. So this would be cosecant squared of x minus 1 multiplied by cosecant x dx. So distribute cosecant x in here. This would be cosecant cube of x minus cosecant x dx. And split the integral apart into two parts. So this would be negative integral of cosecant cube of x dx. And since these are both negative, this should become positive integral of cosecant x dx. As you can see here again, we have a value of integral of cosecant cube of x again. It is the same as the problem right here. So what we're going to do here once again is to just like equate this to each other, because it is true that the integral of cosecant cube of x dx would be equal to this value right here, because it is what we are currently solving. So let me just copy this. And so we must want to eliminate this. So let's get rid of it by adding the integral of cosecant cube x dx to both sides. And so this would be equal to the integral of cosecant cube of x. This will cancel. So this would be equal to negative cosecant x cotangent of x plus the integral of cosecant x dx. And so the next step would be to get rid of this 2 right here, because what we want is something like this. So let us multiply both sides by 1/2 in order to get rid of the 2 here. And so this would cancel. So this would be negative 1/2 cosecant x cotangent of x plus 1/2 the integral of cosecant x dx. And so the last thing that we would want to do here is to get the integral of this one, which we had solved earlier now. And so based on what our answer is earlier regarding the integral of cosecant x, it is equal to the natural log of the absolute value of cosecant of x minus cotangent of x plus c. And so the final answer right here would be equal to negative 1/2 cosecant x cotangent of x plus 1/2 the natural log of the absolute value of cosecant x minus cotangent of x plus the constant of integration. Lastly, the integral of cosecant to the power 5x. So once again, we would want to have to factor out cosecant squared here. And so let this be u and let this be dv. So the formula once again here would be the integral of u dv would be equal to u multiplied by v minus the integral of v multiplied by du. So u right here would be equal to cosecant cube of x. The derivative of cosecant cube of x, since this is chain rule because it has an exponent, focus on the exponent first. 3 cosecant 3 minus 1 would be 2 of x, and multiply this by cosecant, the derivative of cosecant x, which would be negative cosecant x cotangent of x of dx. Rewriting this, du right here would be equal to negative 3 cosecant here would multiply, so you have cosecant cube of x cotangent of x dx. And now dv right here would be equal to cosecant squared of x dx. And so v here now would be the integral of cosecant square, which would be equal to negative cotangent of x. In case you forgot, the integral of cotangent of x would be equal to negative cosecant squared of x. But since what we have here is a positive cosecant squared, so our integral would right here would be equal to negative cotangent. Now that we have our values, let us now put it into this equation. U here is cosecant cube of x. V here would be equal to negative cotangent of x. So let's just put the minus here. Minus the integral of v, which would be equal to negative cotangent of x. And multiply this by du, which is negative 3 cosecant cube of x cotangent of x dx. The minus here would cancel. And so, the simplified form here would be equal to 3. The cotangent here would multiply, so this would be cotangent squared of x multiplied by cosecant cube of x dx. Next step again would be to use this according to its identity. Substitute cotangent squared x according to this identity right here. Let's just put 3 outside for simplification. And so cotangent squared x right here would be equal to cosecant squared x minus 1 multiplied by cosecant cube of x dx. Distribute cosecant cube of x. So this would be cosecant to the power of 5x minus cosecant cube of x dx. And split the integral apart. So this would be negative 3 the integral of cosecant to the power of 5x dx minus 3 the integral of, but since what we have here is both negative, this would be positive 3. Now we had reached the point again where we see cosecant, the integral of cosecant 5 of x, which is also the same as the problem. So let us just equate this to each other. So since we want to get rid of this value right here, let us add or subtract the opposite. Since this is negative, we will add the same value, which would be 3 the integral of cosecant to the power of 5x dx to both sides. So what we have left here is 4 multiplied by the integral of cosecant to the power 5x. This would be equal to the rest of this value. This will cancel to 0. And now the next step would be to get rid of the 4 right here. So multiply both sides by 1/4. This will cancel. And what we have here would be negative 1/4 cosecant cube of x cotangent of x plus 3 multiplied by 1/4 would be equal to 3/4 the integral of cosecant cube of x dx. The next step would be to get rid of the remaining integral here, which is the integral of cosecant cube of x. But since we already had solved that earlier, let's just put the final answer. So this would be this. Plus 3/4 multiplied by the integral of cosecant cube of x. The final answer for that, it would be equal to negative 1/2 cosecant x cotangent of x plus 1/2 the natural log of cosecant x minus cotangent of x. And don't forget to add plus c. That is the final answer regarding the integral of cosecant cube. And so our final answer right here would be equal to negative 1/4 cosecant cube of x cotangent of x plus 3/4 multiplied by negative 1/2. This would be equal to negative 3/8 cosecant x cotangent of x plus 3/4 multiplied by positive 1/2. It would be positive 3/8 multiplied by the natural log of cosecant x minus cotangent of x. And of course, don't forget to add plus c. This is the final answer regarding the integral of cosecant to the power 5 of x.